Right now, in every direction around you, the space just beyond our sun is hiding its closest secrets. Look up on a clear night, and it seems almost empty. But that darkness is not empty at all. Drifting within a few dozen light years of us are dim red stars you cannot see with your eyes, frozen worlds, and stars so strange they seem to break the rules. Some of these neighbors may cradle oceans and the faint chance of life. Others would tear apart anything that came too close. Our nearest neighbor is not even a single star, but three tangled together, and one of the worlds circling them may hold liquid water. And on a few of these worlds, you would look up and see not one sun in the sky, but 2 or 4 or 6. These are our neighbors, and they are stranger and more varied than the night sky ever lets on. One question runs through all of them: which could be alive, and which could kill anything that tried to live there. Chapter 1: Stepping out of the sun's light. Compared to the great galaxies and star clusters scattered across the universe, our whole solar system is barely a speck of dust, and yet, for us, it has always been the entire world. Everyone who has ever lived, every story ever told, every ocean and mountain and quiet evening like this one, all of it has unfolded around a single ordinary star, in a single small pocket of a single arm of one galaxy among billions. So before we travel, it helps to sit for a moment with just how crowded or how lonely that little pocket of space really is. Within about 15 light years of the sun, astronomers have carefully mapped roughly 50 separate star systems. Some are lone stars like ours, drifting by themselves through the dark. Others come in pairs, or threes, bound together by gravity and slowly circling a shared center, locked in a dance that has been going on far longer than there have been eyes to watch it. All told, that small bubble of space holds around 65 stars. Said out loud, it sounds like a busy neighborhood, a place where the streetlights are close together and someone is always nearby. But space is patient with its distances. Out here, the word neighbor means something very different from what it means at home. Let me try to make it real, because the numbers alone will slide right past you. Imagine shrinking our sun down until it was a single grain of sand held in the palm of your hand. On that scale, the very nearest star would be another grain of sand, sitting roughly 40 kilometers away, about 25 miles. 2 tiny grains, one in your hand and one on the far side of a city, with nothing but empty air in between. That is the kind of emptiness we are about to cross, and it is worth letting that sink in, slowly, because our minds are simply not built to feel a distance like that. We can picture the far side of a city. We cannot really picture a grain of sand that far away, floating alone in the dark, and then hold in the same thought that this is the closest thing there is, the nearest of all our neighbors, the short trip, the easy one. Everything else is farther. Some of the worlds we will visit are 10 times that distance, or 20 or more. If our sun is a single grain of sand in your palm, then most of this whole journey unfolds across a landscape the size of a small country, with nothing in it but a scattering of lonely grains, each one a blazing sun, each one separated from the next by an ocean of empty nothing. That is not a flaw in the universe. It is simply how thinly the stars are spread, and it is the first thing you have to make peace with out here, that space is mostly, overwhelmingly, tenderly empty. And even that picture is generous, because the truth is, these stars are not just far apart in space, they are far apart in time as well. Think about what starlight really is. The light carrying each of these stars to your eyes is old. It left some of them 4 years ago, and others 50 years ago or more, and it has been traveling ever since, crossing all that emptiness at the fastest speed the universe allows, just to arrive at your eye in this quiet moment. Some of that light began its journey before you were born. When you look up at the closest stars, then, you are not seeing them as they are. You are seeing them as they were. You are, in the gentlest possible way, gazing into the past. The night sky is less a photograph than a long, slow letter, still arriving. There is a gentle kind of vertigo in that, if you let yourself feel it. Look at any bright star, and the light landing softly on your eye, set out on its journey while the world was a different place. Some of it left before you were born. Some left while your grandparents were young. The star may have flared, or dimmed, or drifted since, and you would have no way to know, because the news of it is still crossing the gulf between you, still years or decades from arrival. In a very real sense, the night sky is not a live view at all. It is a vast collection of old photographs, each one taken at a different moment in the past, all of them pinned up together on the same dark ceiling and mistaken for the present. When you lie back and look up, you are not seeing the universe as it is. You are seeing 1,000 different yesterdays, all at once. And here is the strangest part of all. Most of the stars nearest to us are ones you have never seen and never will, at least not without a telescope. They are red dwarfs, small, cool, dim embers of stars that give off so little light they stay completely invisible to the naked eye. They are by far the most common kind of star in the galaxy, and they crowd our neighborhood, and yet they hang there unseen, quietly burning away for tens of billions of years. The bright, familiar stars that fill our night sky, the ones we name and draw into constellations, are mostly giants, blazing away from far greater distances. They only look close because they are so luminous. Our true neighbors are the quiet ones, the faint ones, hiding in plain sight just beyond the reach of the eye. So the sky you think you know is a little bit of an illusion. The real story of what surrounds us is written in stars too faint to notice, and to read it, we have to leave home. We will move slowly outward, star by star, letting the sun shrink behind us until it becomes just one more point of light among all the rest, no brighter or more important looking than any of its neighbors. It is a humbling thing to imagine, watching our own star dwindle until you could lose it in the crowd. But it is also the only way to truly see where we live. The stars we are about to reach have waited billions of years already, scattered across distances so vast that the journey to each of them stretches out on its own. Moving outward from the sun means crossing that emptiness world by world, letting each one come into view in turn, until our own star is only a memory behind us and the whole strange neighborhood lies open ahead. It helps to hold our own home in mind as a point of comparison: the warm yellow sun, the blue sky, the steady ground. That familiar world is the shape against which everything else out here is measured, and the real surprise of a journey like this is not how alien the other worlds turn out to be. It is how, again and again, they send us looking back at our own quiet corner with new eyes. It is worth pausing too, on how recently we have been able to draw this map at all. For almost the whole of human history, the stars were simply lights, fixed, unreachable, without depth or distance. Looking up, our ancestors had no way to tell whether a bright star was small and close or vast and unimaginably far. A dim star and a brilliant one might sit side by side in a constellation and be nothing alike, one a near neighbor and the other a giant blazing across half the galaxy. It is only within the last century or two that we learn to measure the true distances to the nearest stars at all, by watching them shift ever so slightly against the far background as the Earth swung from one side of its orbit to the other, like holding up a thumb and blinking one eye and then the other. And it is only within the last few decades, within many of our own lifetimes, that we have begun to fill this neighborhood in with actual worlds, sensing distant planets by the faint wobble they give their stars, or the tiny dimming as they cross in front. The map we are about to travel is one of the newest things human beings have ever made. Nearly everything we are about to see would have been completely unknown to anyone born much before you were. We are, in a real sense, the first generation that gets to take this particular walk. Think about that for a moment, because it is easy to rush past. Every person who ever lived before the last century or so looked up at these same nearby stars and simply could not know what we are about to learn here. They could not know that the closest one is really 3, or that a rocky world circles the faintest of them, or that a nearby star races across the sky, or that another holds a sky of 6 suns. All of that was hidden, utterly, behind points of light that gave nothing away. We happened to be alive at the exact moment the answers started arriving. That is an extraordinary piece of timing, and it is worth a little gratitude to be here, now, in the first generation that gets to actually see the neighborhood, rather than only guess at it. So we travel now not only outward through space, but forward through everything we have so recently learned to see. Our first stop is not quite the closest star of all. We will save that small surprise for just a moment. But the direction we travel first will already begin to answer the question we are carrying. Because out here, some of these worlds are gentle and some are not. Before we go far, though, we really should meet the closest of all, and it is not the single, lonely star you might expect. Chapter 2: Alpha Centauri, the neighbor next door. When people picture the nearest star to the sun, they usually imagine a single point of light, alone in the dark, the way our own sun looks alone in its patch of sky. The truth is stranger and far more inviting. Our closest stellar neighbor is not one star at all. It is 3 of them, woven together into a single system we call Alpha Centauri, a little over 4 light-years away. That makes it the closest doorstep in the entire galaxy for us. For as long as human beings have dreamed of reaching another star, this is the door we have imagined knocking on first, simply because it is nearest. Every story we have ever told about traveling to the stars, every imagined voyage, tends to point here first, to this one system, because it is the closest shore across the great dark ocean. If humanity ever does leave the sun behind and set out for another star, the odds are overwhelming that Alpha Centauri is where we will aim. So it is worth getting to know it well. This is not just any neighbor. It is, in a sense, the first rung of a ladder we have only just begun to imagine climbing. And it is a humbling first rung, because even it is so far away. 4 light years sounds almost cozy after all our talk of vast distances, the closest thing there is. But remember what it really means. Light itself, the fastest thing in the universe, takes 4 years to make the crossing. The swiftest craft we have ever launched would take tens of thousands. That is the sobering shape of the gulf between stars, drawn at its very narrowest. If even the nearest doorstep lies that far off, then the neighborhood we are touring is less a place we could ever visit than a place we are privileged to know about at all. A set of postcards from the dark, arriving at the speed of light, from shores no human foot will touch for a very long time to come. 2 of these stars, Alpha Centauri A and B, are close cousins of our own sun, so similar that if you were dropped into their system without being told, you might mistake them for home. They circle each other in a slow, elegant dance that takes about 80 years to complete a single turn, one of them a touch brighter than the sun, the other a touch fainter and more golden. 80 years, about the length of a long human life. A person born on a world in that system might watch the 2 suns swing all the way around each other exactly once, from close embrace to far separation and back, over the whole span of their lifetime, and never see the pattern repeat. Picture, for a moment, standing on an imaginary world, orbiting one of them. Your day would be lit by a sun much like the one you know, warm and yellow-white, familiar enough. But at certain times of year, a second sun would join it in the sky, not a distant point of light, but a fierce, brilliant star, far brighter than anything in our own night sky, bright enough to cast a soft second shadow at your feet. Imagine your own shadow doubled, 2 faint copies of yourself stretching out in slightly different directions across the ground. Imagine an evening where one sun has set, painting the horizon in ordinary colors, while the other still burns high overhead, so that darkness never quite comes, and the night is really only a kind of deep, glowing dusk. There would be seasons of 2 suns and seasons of 1, tides of light rising and falling across the years, as the second star drew near, and then wandered away again. 2 suns, and never quite full darkness. That alone would be wonder enough for one world. But the real prize of this system is not either of those 2 bright stars. It is the third one, the faint one, the one you would actually have to search the sky to find. That third star is Proxima Centauri, a small red dwarf drifting at the outer edge of the group, only loosely bound to its 2 brighter siblings. It is the single closest star to our sun of all, our nearest stellar neighbor in the whole universe, and yet it is so dim that no human eye has ever seen it without a telescope. It is a quiet ember of a star, and circling that quiet ember, astronomers have found worlds. The most famous of them is Proxima Centauri b, a rocky planet with a mass at least a little greater than Earth's. It sweeps around its star once every 11 days or so, at a distance of only about 7.5 million kilometers, roughly 5 million miles. Around a star like our sun, an orbit that tight would be an inferno. But Proxima is so cool and so dim that this snug little orbit places the planet squarely in the habitable zone, that narrow band around a star where the temperature is just right for liquid water to pool on a surface rather than boiling away or freezing solid. Sit with that for a second. The very nearest planet to Earth, Out of all the billions upon billions in the galaxy, maybe a world where rain could fall, where water could gather into pools and seas. Of all the addresses in the cosmos, the one right next door is one where the door might not be locked. It is worth remembering how hard won that knowledge was, because it did not come from a photograph. No telescope simply took a picture of Proxima b. Instead, astronomers watched the star itself for years, hunting for the faintest imaginable wobble, the tiny rhythmic tug of an unseen planet pulling its star back and forth by a few footsteps worth of speed across light years of distance. Teasing that whisper of motion out of the noise took extraordinary patience and instruments of almost unbelievable precision. And when the answer finally came, it was quietly historic. The nearest star to our sun had a planet, and that planet sat where water could survive. Of all the places such a discovery could have landed, it landed on our very doorstep. Sometimes the universe is generous with its coincidences, and this planet is not alone in its system. In more recent years, astronomers picked up the faint signal of a second, even smaller world, Proxima d, a feather-light planet only about a quarter the mass of Earth, whirling around the star in a mere 5 days. That signal was so delicate that it took years to trust. First reported as a hint a few years ago, it was finally confirmed with an entirely separate instrument in 2025, a quiet triumph of patience and precision. So, the closest star to our sun is not a lonely point of light after all. It is a small planetary family, with at least one member sitting exactly where water could survive. But here our question returns, and here is where hope runs straight into hard reality. Proxima Centauri is a flare star. Every so often, without any warning, it erupts. It blasts out ultraviolet light and X-rays in sudden, violent outbursts, far stronger, relative to its size, than anything our steady, well-behaved sun ever throws at us. And Proxima b orbits so close to its star that when one of those flares goes off, the planet is bathed in that radiation, again and again, across the ages. Over millions of years, those repeated floods of energy may have peeled the planet's atmosphere away entirely, stripping it down to bare, scoured rock. So Proxima b is a haunting kind of place to think about. It is the nearest world to us where liquid water might exist, and, at the very same time, a world that may have been sterilized clean long before life ever had the chance to begin. Close, familiar, tantalizing, and possibly quite dead all at once. It is a reminder that being in the habitable zone is only the beginning of the story, not the end of it. And yet, even knowing that Proxima b may be a scoured and lifeless place, it is hard not to feel a pull toward it. There is something almost unbearably close about it. 4 light years is still an impossible distance by any human measure. If you set out today on the fastest spacecraft we have ever built, you would not arrive for tens of thousands of years, longer than all of recorded history stretched end to end. And yet, on the scale of the galaxy, 4 light years is nothing at all. It is the very next doorstep. If the Milky Way were a great city, Proxima would be the house immediately next to ours, close enough to see the light in its windows. To know that there is a rocky world right there, right next door, sitting where water could pool, and to know that we may never, in any of our lifetimes, truly reach it, is a particular kind of ache. It is the ache of standing at a window, looking at something beautiful just outside, with the glass between you and it. And yet, even that ache is a kind of privilege. To be able to stand at the window at all, to know there is something out there worth aching for, to have measured the world beyond the glass and found it real. Our ancestors could not even do that much. The distance is the same distance it always was. What has changed is that we can finally see across it and name what we see and let ourselves long for it. That longing, in its quiet way, is one of the more human things we do, to look at the unreachable and love it anyway. Even so, this system pulls at us like no other place in the sky. It is near enough that, for the first time in history, we have begun to dream seriously and concretely about actually reaching it. One project, called Breakthrough Starshot, has studied sending not a great heavy ship, but a swarm of tiny probes, each one no larger than a computer chip, each riding on a gossamer sail pushed by a battery of powerful lasers fired from Earth. The idea is to accelerate these feather light travelers to a fair fraction of the speed of light itself, so that they could cross those 4 light years, not in tens of thousands of years, as an ordinary rocket would need, but in something like 20. It is an audacious plan, still far from anything we can build today. But the fact that we are seriously working on it at all, the fact that reaching another star has moved from pure fantasy into engineering studies, is entirely because Alpha Centauri is close enough to make the dream feel almost touchable. And even if those tiny probes are never built, even if no machine from Earth ever crosses that gulf, there is something worth holding on to in the simple fact that we tried to imagine it. For all of human history, until almost yesterday, the stars were fixed and untouchable, as far beyond reach as heaven itself. To have reached the point where we can seriously sketch a route to another sun, to name the star, measure its planet, and begin drawing the map, is its own kind of quiet milestone. We may be the first generation that could point at a specific star, a real place with real worlds, and say, honestly, that is where we might one day go. The distance has not shrunk, but somehow, for the first time, it has stopped feeling entirely impossible. And so we leave Alpha Centauri the way we will leave every stop on this journey, with more questions than answers, and a quiet backward glance. 3 suns, a rocky world where rain might once have fallen, and a temperamental little star that may have burned it clean. Our nearest neighbor turns out to be neither the welcoming twin of science fiction nor an empty dead rock, but something in between, and far more interesting than either, a real place, close enough to dream of, strange enough to keep us wondering. The nearest star we can actually watch moving across our sky, though, lies in an entirely different direction, and it travels faster than any other star we know. Chapter 3: Barnard's Star and the Ocean That Might Hide Beneath the Ice. We turn now away from the brilliance ahead of us and towards something almost its opposite, a star so faint that for most of history no one knew it was there at all. About 6 light years away sits a small, faint red dwarf known as Barnard's Star. It gives off barely 1,000th of the sun's light, a dim red coal of a star, so faint that you will never once glimpse it by simply looking up, no matter how dark your sky. And yet, in the quiet world of astronomy, Barnard's Star is genuinely famous, and it is famous for one thing above all. It moves. Every star in the sky drifts, very slightly, over the ages, but Barnard's Star races. It crosses our sky faster than any other star we know, sliding the full width of the moon against the background of more distant stars in roughly 180 years. That may not sound quick, but for a star, it is a headlong sprint. An astronomer who photographs it at the start of a career, and again near the end, can actually see how far it has shifted with their own instruments within a single working lifetime. It is racing toward us right now at over 140 kilometers a second, and it is drawing closer. In a few thousand years, this faint red ember will have crept in to become one of our very closest neighbors of all, and for a while, it will hold that title. Try to picture that speed for a moment. 140 kilometers every single second, fast enough to cross the entire width of our own planet in less than a minute, and it holds that pace without pause, year after year, century after century, silently closing the distance between us. We will not be here to greet it when it arrives at its nearest. Whole civilizations will rise and fall in the time it takes this one dim star to complete its approach, and yet it comes on, steady and patient, a slow red traveler on a journey measured not in years, but in the lifetimes of species. There is something quietly moving in that thought, that the arrangement of stars around us is not fixed and eternal, but slowly reshuffling, and that our list of nearest neighbors will look different long after we are gone. There is something worth sitting with in that slow, relentless motion. We tend to picture the night sky as permanent, the same constellations our grandparents saw, the same ones our distant descendants will see. But that permanence is only an illusion of the short time we each get to look. Give it long enough, and stars like Barnard's redraw the map entirely. The familiar shapes we trace overhead will slowly stretch and break apart. New neighbors will drift in close, and old ones will wander away into the dark. The sky is not a painting. It is a slow, silent river, and we only ever see one still frame of it, the one that happens to fall within a single human life. Barnard's star is simply the fastest of these silent swimmers, the one moving quickly enough that we can actually catch it in the act within a lifetime. But every star up there is drifting, each on its own long path, the whole pattern slowly flowing and rearranging over spans of time, so vast they make a human life look like the blink of a shutter. The constellations you learned as a child are not eternal. Given enough time, hundreds of thousands of years, millions, they will stretch and sag and dissolve, and new shapes we have no names for will take their place. We are lucky, in a way, to catch the sky in the particular arrangement we did. It is ours, this frame of the river, and it belongs to no one who came before us, and no one who will come long after. For a long time, this ancient star, and it is ancient, perhaps 10 billion years old, one of the oldest stars we have ever identified, older than the sun by more than twice over, seemed to be a lonely traveler, racing through the dark with nothing to keep it company. Then, only recently, that changed. And the way it changed is a good and humbling lesson in how carefully we have to hold everything we think we know about these distant places. For years, there was a claim of a single large planet circling Barnard's star on a cold, far-flung orbit. It was an exciting idea, and it was reported widely, but it did not survive closer inspection. The signal, studied more carefully, simply melted away. Then, in 2024, astronomers turned an extraordinarily sensitive instrument mounted on one of the giant telescopes in the Chilean desert, toward the star and watched it for 5 patient years. What they found was something quite different from the old claim: a tiny world, less than half the mass of Earth, whipping around the star in just over 3 days. And they did not stop there. By 2025, follow-up work had revealed not one planet, but a family of 4, every one of them smaller than Earth, all of them orbiting very close to their dim red star. So Barnard's star does have a planetary system after all, right here on our doorstep. But there is a catch, and it matters. Every one of these little worlds hugs its star so tightly, circling in a matter of days, that they are almost certainly far too hot and far too battered by their star's light to hold on to any atmosphere. As far as we can tell, not one of them could support life. The doorstep has worlds on it, but the door is sealed shut by heat. It is a small disappointment, and an honest one, and worth sitting with rather than rushing past. We would love for the nearest systems to be brimming with gentle Earths. But the universe owes us nothing, and again on this journey, it hands us worlds that are close and real and fascinating and simply not habitable. That is not a failure of the search. It is the search, working exactly as it should, trading comforting fantasies for genuine knowledge, one careful measurement at a time. Barnard's 4 little worlds are not places we could live, but they are real, and they are ours to know. And a few years ago, we did not even know they were there. Knowing a true thing, even a disappointing one, is its own kind of quiet gain. And there is a strange warmth in that hidden ocean idea that stays with you as you travel on. The thought that even here, around a cold, dim star that will never warm a surface, life might still find a way in the dark, tucked beneath the ice, patient and unseen. We do not know that it is there. Almost certainly, around Barnard's little worlds, it is not. But the possibility itself, carried out into the emptiness, changes how the whole journey feels. The dark is no longer simply empty. It is full of maybes. And a sky full of maybes is a very different sky to travel under than a sky full of certain nothing. It is what keeps us building telescopes, keeps us leaning out into the cold, keeps this whole long search alive. Not the answers we have, but the maybes we have not yet ruled out. And yet the deeper idea that first drew our attention to cold, dim stars like this is still worth holding on to, because nature has quietly shown us that it can be true, just not always in the place we first went looking. To see how, we do not even have to leave home. Think of our own solar system, far out past Jupiter and Saturn. There, the moons Europa and Enceladus are frozen solid on the outside, their entire surfaces locked beneath shells of ice, sitting in cold and darkness far from the sun's warmth. By every simple measure, they ought to be dead worlds. But they are not. Beneath that ice, the constant pull and squeeze of their planet's gravity kneads their interiors and keeps them warm, and there, hidden away from the cold and the dark, sheltered under kilometers of ice, are genuine oceans of liquid water. Some of the most promising places to search for life in our entire solar system are not the warm, sunlit worlds we might picture at all. They are these frozen moons, with hidden seas tucked quietly underneath. There is a strange comfort in that idea, and it is worth resting on for a moment. It means that a world does not have to look welcoming to be alive. It does not need blue skies, or warm sunlight, or oceans lapping at open shores. Life, if it is anything like the stubborn, resourceful thing we know on Earth, might take hold in the most unpromising darkness, in a black sea beneath a roof of ice, warmed only by the slow flexing of a moon, lit by nothing at all. If that is true, then the number of places worth searching swells enormously. Every frozen world, every dim red dwarf's cold companion, every lonely wanderer far from any sun, becomes a place where the light might simply be on the inside, waiting, hidden, patient. We have been looking for other Earths, but we may have been looking for the wrong thing. The living worlds, if they are out there, might not look like home at all. So when we look at a cold, dim system like Barnard's star, the real lesson is not that life is impossible out here in the dark. It is that life, if it exists in places like this, may not be waiting for us on bright, warm, sunlit surfaces where it would be easy to spot. It may be hiding beneath ice, beneath rock, in warm and quiet water that never once sees its star. We have not found it there. We may never. But we have at least learned something important on our own doorstep: never to mistake a frozen surface for a dead world. Sometimes the light is simply on the inside. On the far side of the sun waits the exact opposite of this dim, quiet ember, the single brightest star in all of our night sky. Chapter 4, Sirius, the diamond of the sky, and the ghost beside it. From the faintest star in our journey, we now turn to the very brightest. Everything about Barnard's star is quiet, dim, and easily overlooked. Sirius is its opposite in every possible way. It is the brightest star in our entire night sky, blazing down at us from about 8.5 light years away, so brilliant and so unmistakable that ancient cultures across the world built calendars, myths, and whole seasons around its rising. The Egyptians watched for it to herald the flooding of the Nile. Sailors steered by it. If any star beyond the sun has shaped human life, it is this one. For the ancient Egyptians, its first appearance in the dawn sky each year came just before the Nile began to rise and flood their fields, and so this single star became a kind of celestial clock, marking the turn of their whole agricultural year. Cultures across the world wove it into their calendars, their navigation, their myths of the seasons. For thousands of years, before anyone knew what a star truly was, people ordered their lives in part by this one brilliant point of light. There is something moving in that long before we understood the stars at all, we still leaned on them, still let them shape how we lived. Sirius has been keeping time for human beings since long before human beings knew what it was. And yet, like so many of our neighbors, what looks to the eye like a single dazzling point of light is really two stars keeping close company in the dark. The star we actually see, the one doing all that blazing, is Sirius A. It is a hot, blue-white sun, about twice the mass of our own and considerably larger across. Its surface burns at nearly 10,000 degrees, almost twice as hot as the sun's face, and it pours out around 25 times more light than our star does. It is a genuine beacon, a lighthouse in our corner of the galaxy, but hidden in its glare, drowned out for centuries by all that brilliance, is something small, faint, and utterly remarkable. A companion star called Sirius B. Sirius B is a white dwarf, the burnt-out, collapsed core of a star that has already lived its life and died. And it hides one of the most staggering facts in our whole neighborhood. This little star is only about the size of the Earth, a small ball, no bigger across than the planet under your feet. And yet, crushed into that tiny sphere, it holds nearly as much mass as our entire sun. Try to hold those two facts together in your mind, because they do not want to sit together. The size of the Earth and the weight of the sun packed into the same object. The matter inside it is squeezed so impossibly tight that a single spoonful of it, scooped out and brought here, would weigh several tons on Earth, as much as a car balanced on a teaspoon. This is not ordinary matter anymore. It is stellar ash, the compressed cinder of a dead star, packed to a density almost beyond what the mind can picture. The story of how we even found that faint companion is a small marvel in itself. For a long time, no one saw Sirius B at all. But astronomers watching the bright star noticed something strange. Sirius A was not moving in a straight line through the sky. It wobbled ever so slightly, as though something unseen were tugging at it. Long before anyone laid eyes on the companion, they knew, from that gentle swaying alone, that a hidden mass had to be there, pulling on the star we could see. Only later, with better telescopes, was the tiny white dwarf finally caught, glimmering right where the wobble said it must be. It is a lovely reminder of how much of this neighborhood we have mapped, not by looking directly, but by watching what the dark does to the light around it, reading the invisible from its fingerprints on the visible. So much of astronomy turns out to work this way. We rarely get to see the thing itself. We see its shadow, its pull, its faint effect on something brighter beside it. A planet betrays itself by the tiny wobble it gives its star, or the sliver of light it blocks as it crosses in front. A dead companion reveals itself by tugging its living partner off a straight line. Whole invisible worlds are mapped from nothing but the gentle disturbances they leave in the light we can see. There is a kind of patience and humility in that method, a willingness to sit and watch and infer, to trust that the universe leaves honest fingerprints even on the things it hides. Almost everything we know about our neighborhood, we learned not by reaching out and touching it, but by looking very carefully at what refused to stay perfectly still. And there is a quiet, almost poignant twist hidden in this pair of stars. You might naturally expect the faint, dead companion to be the younger of the two, the one that never quite grew up. It is exactly the other way around. Sirius B was once the heavier of the pair, a star perhaps 5 times the mass of the sun. And here is the cruel arithmetic of the cosmos. The heavier a star is, the faster it burns through its fuel, and the sooner it dies. So the more massive star raced through its whole life, swelled up, and collapsed into the white dwarf we see today, around 120 million years ago, while its lighter, more patient partner is still shining away in the prime of its life. The star that looks older and deader is the one that was, in truth, born to burn out first. Brilliance and brevity tied together. It is a pattern that repeats all across the cosmos, and there is a quiet lesson in it for us. The brightest, heaviest, most spectacular stars are almost always the ones that die youngest. They burn with such fury that they exhaust themselves quickly, blazing gloriously, and then guttering out, sometimes in only a few million years, a mere eye blink in the life of the universe. The small, dim, unremarkable stars, the ones nobody writes myths about, are the ones that endure. A little red dwarf like Barnard's or Proxima can burn steadily for tens or even hundreds of billions of years, far longer than the universe has so far existed. So the sky plays a quiet trick on us. The stars that catch our eye, the dazzling ones, are the brief ones, and the faint ones we overlook are the ones that will still be shining long after the beacons have gone dark. There is something almost gentle in that, a reminder that lasting and dazzling are rarely the same thing, out here or anywhere. So what lies ahead for bright Sirius A, still blazing in its prime? Here we have to be careful, because it is very easy to reach for a dramatic ending that simply is not true, and this is exactly the kind of place where stories about space so often go wrong. Sirius A will not explode. It will not end its life in a supernova. To die that violent way, a star needs to be at least 8 or so times the mass of the Sun, and Sirius A, at around 2 solar masses, falls far short of that mark. Its fate is gentler and slower, and in its own way more beautiful. In a few 100 million years, it too will swell up into a red giant, its outer layers billowing outward, and then it will gently shed those layers into a soft, glowing shell of gas, leaving behind only its own dense, hot core. And that core will settle down over the long ages into a white dwarf, following the very same quiet path its companion has already walked before it. In the far distant future, this dazzling diamond of our night sky will become a second pale ember, and the two of them will drift on together as a pair of dead stars, circling each other in the dark, long after anyone is left to name them. There is a strange tenderness in imagining that far future. The brightest star in all our sky, the one that has guided sailors and inspired myths for as long as there have been people to look up, will one day simply go quiet, not in a blaze, not in a catastrophe, but gently, swelling, cooling, letting go of its outer layers, and settling into a small warm cinder that slowly, over billions of years, fades toward black. Everything shines for only a while. Even the brightest beacon in our heavens is, in the end, just passing through its moment of brilliance, on its way to the same quiet dark that waits for every star. Somehow, that does not make Sirius less beautiful. If anything, knowing it will not last forever makes its blaze feel a little more precious. There is a lesson in that we can carry back down to earth with us, if we like. Nothing that shines, shines forever. Not stars, not worlds, not the brief, bright span of a life. And that is not a sadness so much as the very thing that gives light its value. A sun that burned unchanged for all eternity would be a kind of furniture easy to ignore. It is precisely because Sirius will one day fade, because our own sun will one day change, because none of this is permanent, that any of it is worth looking up at all. The impermanence is not the flaw in the beauty. It is the reason there is any beauty to notice at all. So we leave Sirius still blazing, still the brightest jewel in the sky, and carry that small quiet truth onward with us into the dark. Everything out here is passing through its own bright moment, ourselves included. That is not a reason for sorrow. It is the very thing that makes the whole crowded, shining, temporary sky worth crossing. A short course correction now carries us onward, to a small red star that hides not one world, but three. Chapter 5. Wolf 161. One star and three rocky worlds. About 14 light-years from Earth glows another dim red dwarf, this one called Wolf 161. On its own, it would be entirely unremarkable, just another faint, cool, long-lived star among the countless red dwarfs that quietly fill our neighborhood, the kind of star we have already learned to look past. But this one is not empty-handed. It carries a small family of planets, and those planets tell a quietly profound story about how differently worlds can turn out, even when they are born around the very same star, from the very same cloud. 3 rocky planets circle Wolf 1061, and each one has met a very different fate. The innermost is a scorched, punished world, orbiting so close to its star that one side very likely faces it forever. One hemisphere baked in permanent, blistering daylight, the other locked in endless frozen night, with no sunrise or sunset ever crossing between them. The outermost planet follows a stretched, uneven orbit that never quite settles into comfort, swinging closer and then farther as it goes. But it is the middle world that makes astronomers lean in and pay attention. It is called Wolf 1061c, and it sits, remarkably, inside the habitable zone. Wolf 1061c is what we call a super-Earth, a rocky planet noticeably more massive than our own, weighing in at around 3.5 times the mass of Earth. It circles its star once every 18 days, close enough to its dim red sun to stay warm, but not so close that it is roasted like its unfortunate inner sibling. When it was first announced, back in 2015, it was the nearest potentially habitable world we knew of anywhere, though in the years since, we have found a small handful of candidates closer still. Whether it could truly host life remains genuinely uncertain, and it is worth being honest about that uncertainty rather than promising more than we know. But it sits squarely in that narrow, precious band where liquid water is at least possible, and that alone makes it one of the more tantalizing addresses in our entire neighborhood. And standing on such a world would feel unfamiliar in your very bones, literally. With more than 3 times the mass of Earth, its surface gravity would pull on you noticeably harder than the gravity you have known your whole life. A person who weighs 70 kilograms at home, a little over 150 pounds, would feel distinctly, tiringly heavier there. Every step would take more effort. Lifting your own arm would feel like a small chore. Your body would feel constantly reminded that it was standing on a world that grips harder than the one it grew up on. And above you, that red dwarf sun would hang large and deep orange in the sky, its light dim and ruddy and warm, never quite reaching the brilliance of our own noon. It would cast long, coppery shadows across the ground at every hour of the day. Picture it, a quiet, heavy world, under a quiet, patient star, bathed forever in a kind of permanent, golden late afternoon light that never quite becomes either morning or evening. And that permanence has a strange beauty to it if you let yourself sink into the thought. On such a world, if it faces its star the way its scorched inner sibling does, there would be no sunrise and no sunset at all. The red sun would simply hang in one fixed place in the sky, unmoving, for as long as you cared to watch, century after century, in exactly the same spot. There would be a place on that world where it was always dawn, frozen at the horizon, and a place where it was always deep night, and a narrow ring between them, a band of endless ruddy twilight, where any gentle weather and any liquid water would most likely gather. Astronomers actually have a name for that thin habitable band on a locked world, the terminator, the dividing line between the eternal day side and the eternal night side. It is one of the stranger places to imagine life taking hold, not spread across a whole warm world as it is on Earth, but strung out along a single ring of permanent sunset, caught forever between fire and ice. Step too far toward the sun, and you burn. Step too far away, and you freeze. But in that narrow ribbon of dusk, if an atmosphere could carry the warmth around and soften the extremes, there might just be room for something to live, hugging the twilight, following the one gentle line on an otherwise unlivable world. It stretches the imagination to picture what a living thing there might even be like, shaped by a sun that never moves, a landscape with no days, warmth on one side and cold on the other, and the only mildness a thin line running clear around the world. If life arose in such a place, it would know nothing of morning or evening, nothing of the turning of a day. Its whole sense of the world would be built around that unmoving red sun and the fixed, gentle band beneath it. We so often imagine alien life as a version of ourselves. But worlds like Wolf 1061c are a reminder that life, if it exists out here at all, might be shaped by rules so different from our own that we would struggle even to recognize the questions it asks of its own strange sky. Imagine living your whole life in that thin ring of permanent dusk, under a sun that never rises and never sets, in a stillness our restless spinning earth has never known. It is a kind of peace almost impossible for us to picture, and a reminder that even the rhythm of day and night, which feels so fundamental to us, is just one way for a world to be. We take our days and nights so completely for granted. The reliable rising and setting of the sun, the turn of morning into evening, is woven into everything we are, our sleep, our stories, our sense of time itself. And yet it is not a law of the universe. It is just a happy accident of how fast our particular world happens to spin. Out here, around other stars, there are worlds locked still, worlds that never turn, worlds bathed in permanent day, or permanent night, or frozen forever in a single unchanging dusk. Our gentle cycle of light and dark, the thing that feels most ordinary about a day, turns out to be one of the rarer and stranger gifts of home. There is a quiet lesson tucked into this one small system, and it is worth carrying with us for the rest of the journey. 3 worlds born together from the same swirling disk of gas and dust around the same star, and yet they could hardly have turned out more differently. One is a scorched, half-frozen prisoner locked facing its sun. One rides a restless, uneven path, and one sits in the gentle middle ground where water might just survive. It did not take different stars to make such different fates. It only took slightly different distances, slightly different orbits, and our own solar system is exactly the same kind of story: scorched Mercury, gentle Earth, and frozen Neptune, all children of one sun, all utterly unalike. Small differences, compounded over billions of years, are the difference between a desert and an ocean, between a dead rock and a living world. It makes you look at our own comfortable place around the sun a little differently, as something that could so easily have been otherwise. and it puts the whole search for other worlds in a humbling light. When we scan these distant stars for planets in the habitable zone, we are really asking a very narrow question. Is there a place where the numbers happen to line up the way they lined up for us? A world not too close and not too far, not too heavy and not too light, around a star not too fierce and not too dim, holding on to just enough air and just enough water for long enough. So many small things had to fall into place for Earth and stay in place for billions of uninterrupted years that when you lay them all out, it starts to look less like an ordinary outcome and more like a long, improbable run of good fortune. That does not mean we are alone. The galaxy is vast, and vastness has a way of making even rare things happen somewhere. But it does mean that a gentle, living world is a delicate achievement, not a given. Wolf 1061's three siblings, so different from one another, are a small reminder of just how many ways a world can go wrong, and how few ways it can go right. And traveling on from that thought, we carry a gentler appreciation for the ground beneath us. Earth did not have to be temperate. It did not have to hold on to its air, or its water, or its steady tilt, and its life-giving distance from the sun. It simply did, and kept doing so, for the billions of uninterrupted years that life needed. Every world we visit that failed to manage that same quiet trick makes our own success look a little less ordinary, and a little more like a small, improbable grace we happen to be born into. This star, so easy to overlook, sits right at the very edge of something enormous that we are all sailing through at this very moment. And most people go their whole lives without ever learning its name. Chapter 6: The Cloud We Are Drifting Through and Why Everything is Flat. We tend to think of the space between the stars as pure, perfect emptiness, a clean vacuum with nothing in it at all. It is not. Our sun, and every planet riding quietly along with it, including this one beneath you, is currently drifting through a vast, thin cloud of gas known as the local interstellar cloud. We sailed into it around 10,000 years ago, near the dawn of human civilization, and we will keep sailing through it for a few thousand years more before we finally pass out the other side into an even thinner, hotter region of space beyond. We are, in a very real sense, weather, moving through a larger climate we can barely perceive. This cloud is made mostly of hot, wispy hydrogen, stretched so unimaginably thin that for all its heat, it poses no threat to us whatsoever. Our sun helps see to that. The constant stream of particles it blows outward in every direction, the solar wind, pushes against this cloud and holds most of it at bay, carving out a protective bubble around the whole solar system. And whatever manages to slip through, Earth's own thick atmosphere quietly absorbs. We are shielded twice over, by our star and by our air, without ever noticing. It is easy to forget how much stands between us and the raw universe. Step outside on any ordinary night, and the air feels like nothing at all. The empty sky like a harmless backdrop. But that thin skin of atmosphere overhead, and the invisible bubble of our star's wind stretching far beyond the planets, are quietly turning aside a constant sleet of radiation and interstellar particles that would otherwise fall on us unfiltered. We live our whole lives at the bottom of a well of protection we cannot see and did nothing to earn. Born already sheltered, taking it entirely for granted. The calm of an ordinary evening is not the absence of danger. It is danger, held gently at bay, just out of sight, by defenses older than we are. And that, quietly, is one of the gentle threads running through this entire journey. Everywhere we have gone, we have found worlds exposed, scorched by their stars, stripped bare by flares, frozen in permanent dark, battered by radiation, with no shield to soften it. And then we come home, to a world wrapped in air and magnetism and just the right distance from a steady, patient sun, and we realize how much quiet good fortune it took to make a place this safe. We do not usually think of Earth as lucky. It just feels like the way things are. But set against all these other worlds, our ordinary sheltered evening starts to look like one of the rarest things in the sky. And yet we do have proof that pieces of this larger cosmic story reach us anyway. Buried in the sediment of the deep ocean floor and locked into the ancient snows of Antarctica, scientists have found faint traces of a rare form of iron called iron-60. That particular kind of iron is not made in quiet places. It is forged only in the hearts of exploding stars. Its presence here, in our oceans and our ice, is a quiet fingerprint left behind, hard evidence that the debris of distant, long-ago supernovae has drifted across the light years and settled softly, invisibly, onto our world. The dust of dead stars is already part of the Earth. It is one of the most quietly astonishing facts in all of science, and it deserves a moment of stillness. The iron in your blood, the calcium in your bones, the oxygen you are breathing right now, none of it was made on Earth. All of it was forged inside stars, most of them long dead, and scattered across space when they died, drifting for ages before gathering into the cloud that became our sun and our world and, eventually, us. We are not separate from the sky we have been traveling through. We are made of it. Every atom in you was once inside a star, and that faint dust of ancient supernovae, still settling softly onto Antarctic snow, is just the latest delivery in a story that made you, too. You are not looking out at the universe from the outside. You are the universe, briefly gathered into something that can look up and wonder, and drifting on through this thin cloud, sheltered and small, made of old starlight. It is worth carrying that thought outward with us, like a warm coat against the cold of all these distances. However far we travel, however strange and unreachable the worlds we meet, none of it is truly foreign. We are kin to all of it, built from the same scattered ash, riding the same slow currents through the same quiet dark. The universe is not a place we are visiting, it is a place we belong to. Now, while we are drifting here through this cloud, it is worth slowing down to wonder about something we almost never stop to question. Why is the solar system flat at all? The planets all orbit in roughly the same plane, like marbles rolling across a tabletop, rather than swarming around the sun from every direction like bees around a hive. It did not have to be this way, and the reason it is this way is stranger and more wonderful than it first appears. When a great cloud of gas collapses inward to form a star and its planets, that cloud is always gently spinning, and its spin defines a single plane, a preferred direction to the whole turning motion. Now, particles that stray above or below that plane keep crashing into one another, and each collision cancels out a little more of the up and down motion, the wasted motion. But the one thing those collisions can never cancel is the spin itself. And so, over long ages, the cloud settles, and thins and flattens, collapsing down into a broad turning disk. That is why our solar system is a plate and not a ball. But here is the truly strange part, the part that can quietly rearrange how you see everything. This flattening only works because we happen to live in a universe with 3 dimensions of space. If space had 4 dimensions instead of 3, the mathematics would change completely. The spin could spread itself across 2 separate planes at once, with no single up or down direction left for those collisions to cancel out. The cloud would never flatten. It would stay a formless, swarming ball, and planets like the one you are sitting on might never gather together at all. So the flatness of our solar system, the orderly plane the planets share, and in a very real sense our own existence, is a quiet gift of living in exactly 3 dimensions. Not 2, not 4, 3. Sit with that the next time the number 3 seems ordinary. It is one of those quiet facts that, once you really take it in, subtly changes the way the whole night sky looks. Every disk in the universe, the flat plane of our planets, the broad spiral of the Milky Way, the rings around Saturn, the swirling platter of gas around a newborn star, is telling you the same story. Each one is the frozen signature of a spin that could not be undone, in a universe that happens to have exactly the right number of dimensions for spinning things to settle into disks. We live inside a cosmos that flattens, that organizes, that turns formless clouds into orderly rings and worlds. It did not have to be that way, and the fact that it is that way is written into the very shape of everything around us. The plane, the planet's ride, the band of the Milky Way arching across a dark sky, the disk of dust that our own Earth was born from 4.5 billion years ago. Flatness is not a coincidence. It is a fingerprint pressed into the whole universe of the simple gift of 3 dimensions. And there is one more quiet wonder tucked into that. The same simple rule that flattened our solar system into a plane and that first let planets like ours gather at all is still shaping things we are only now learning to see. It is why we spent all these centuries looking at our own sun edge on, blind to its poles, until a single brave spacecraft finally climbed high enough to look down. The flatness gives us our worlds, and it also, quietly, hides things from us, keeps certain directions and certain views out of reach until we work hard enough to earn them. The plane that made us is also, in its way, a wall, and every so often we manage to peek over it, and the universe shows us something it had been holding just out of sight all along. And there is one more piece of this flat arrangement that we have only just, in our own time, begun to see with our own eyes. Because everything orbits within that single plane, including all our spacecraft, we have spent the entire history of astronomy looking at the sun from the side, along its equator, the way you might only ever see a spinning coin edge on. Its poles, the very top and the very bottom of our star, have stayed almost completely hidden from us all this time. That changed in 2025. A spacecraft called Solar Orbiter climbed, with enormous effort, high enough above the plane of the planets to finally look down on the sun's south pole for the first time, from an angle no human eyes and no instrument had ever held before. And what it found was a surprise. The magnetic field down at the pole was not neat and orderly, but a tangled, chaotic mess, with both north and south magnetic polarity jumbled together in the same place. Because the sun happens right now to be at the stormy peak of its activity cycle, the very moment when its whole magnetic field is in the middle of flipping over. Think about that for a moment. Even our own star, the closest star in all the universe, the one we have watched every single day for the whole of human history, is still, even now, showing us entire sides of itself we have never once seen. And there is something almost tender in that double shelter, once you notice it. We spend so much of our time feeling exposed and small against the vastness of space, and we are small, but the vastness is not simply out to get us. Our star wraps a bubble of its own wind around us, and inside that, our planet wraps a thin skin of air around itself, and inside that, we go about our quiet lives, mostly never feeling the cosmic weather at all. The radiation, the interstellar wind, the debris of exploded stars, almost all of it is turned aside before we ever know it was there. To live on Earth is to be held, gently and constantly, by defenses we did not build and rarely think to thank. Not every star, though, gets to age this quietly. One star not far from here was thrown violently out of the place it was born, and it is barely older than the flowers on our planet. Chapter 7: A.P. Columbae, the Runaway Child. We have met old stars and steady ones. Now we come to a genuine newborn. About 27 light years away lives one of the very youngest stars in our whole neighborhood, a small red dwarf named A.P. Columbae. To call it young is almost an understatement. It was born only around 40 million years ago, which sounds like an enormous span, until you set it against the sun's 4.5 billion years, or the 10 billion years of ancient Barnard's star. To put it another way, when A.P. Columbae first flickered into life and began to shine, the dinosaurs were already long gone from the Earth. In the long, slow lifetimes of stars, this one is a newborn, still practically glistening, and it has a genuinely wild story hidden in its past. Because A.P. Columbae did not form where we find it today. Astronomers who carefully traced its motion backward across the sky made a surprising discovery. This star was born far away, in a crowded cluster of young stars hundreds of light years from where it now sits. That is not how things usually go. Young stars, like young anything, tend to linger near their birthplace for a long time, drifting slowly together with their brothers and sisters, held loosely in the family group where they formed. But something threw this one out, hard. The most likely story is a violent one. One of its sibling stars exploded as a supernova, and the sheer force of that blast kicked A.P. Columbae free of the whole group, flinging it off across the galaxy entirely on its own. It is a runaway, a child star hurled out of its nursery in a moment of cosmic violence, and left to wander the dark alone ever since. There is a strange loneliness in that image that is hard to shake. Most stars drift through life loosely accompanied, born in clusters, keeping some faint company with their siblings for ages before slowly dispersing. But this one was torn free early and thrown clear, sent tumbling out into the emptiness on its own, long before its time. It will spend the rest of its enormous life as a solitary wanderer, crossing the galaxy alone, never again near the family it was born into. And it does not know any of this, of course. It simply burns and flares and drifts. But from the outside, watching, it is difficult not to feel something for the little runaway, a small, fierce, orphan star, making its long way through the dark. Set that against the gentle old age of Barnard's star, and you begin to see the whole span of a stellar life laid out across our neighborhood. The turbulent newborn, flaring and unstable, the steady middle years, like our own sun, the long, quiet fading of an ancient red dwarf, and the crushed white cinder left behind at the very end, like Sirius B. We are not just touring stars, we are touring ages, catching each of our neighbors at a different moment in a life so long that we can only ever glimpse a single frozen instant of it. The night sky, seen this way, is not a still scene at all. It is every stage of a life, all present at once. And remarkably, we can read this star's youth directly in its light. AP Columba's atmosphere is unusually rich in a delicate, fragile element called lithium. Lithium is something like a baby tooth for a star. It is present when a star is very young, but it burns away and vanishes quickly once the star settles into the long, steady middle stretch of its life. So finding so much lithium still present, still glowing in this star's light, is like finding baby teeth in a creature and knowing at once that it must be very young indeed. It tells us AP Columbae is not yet fully formed, still unsettled, still in the very earliest chapter of its existence. And youth, for a red dwarf, is a turbulent thing. This star is restless and unstable, prone to sudden, violent outbursts that can briefly flare it many times brighter in a matter of moments. It is worth pausing on how much we can learn about a place we will almost certainly never visit, simply by reading its light with enough care. We have never sent anything to AP Columbae, and never will in any lifetime we can imagine. And yet we know its age, and its temper, and the fact that it is a wanderer far from home, and even the story of the violent event that set it loose. All of that, teased out of a faint smear of light that took 27 years just to reach us. This is the quiet magic that runs underneath this entire journey. Every fact we have spoken, every mass and distance and temperature, every ocean that might hide beneath ice, every sky full of suns, was pried out of starlight alone by people patient enough to look closely and clever enough to understand what they were seeing. We are reading the biographies of stars we can never touch, written in a language of light, across distances that would swallow a human life whole. And there is something deeply hopeful in that when you sit with it. It means that distance, for all its cruelty, is not a complete barrier. We cannot go to these stars, but their light comes to us freely, endlessly, carrying its quiet cargo of information across the dark, and we have taught ourselves to read it. A star does not have to be reachable to be knowable, and so the whole vast neighborhood, unreachable as it is, becomes an open book after all, its pages written in light, waiting only for eyes patient enough and clever enough to make out the words. We may be small and slow and bound to one little world, but our looking reaches everywhere. And AP Columbae, restless and far away as it is one more place that looking has reached, a young, wild, orphan star whose whole story we have gathered from a thread of light without ever leaving home. That is the quiet triumph hiding inside this small chapter. Not that we can go there, but that we can know it at all. And this is where the darker half of our question returns to us. Those outbursts are exactly the kind of thing that And this is where the darker half of our question returns to us. Those outbursts are exactly the kind of thing that makes a young red dwarf so dangerous to anything trying to live nearby. A single powerful flare erupting from a star like this and striking a nearby planet would tear away that planet's atmosphere and scour its surface with a flood of ultraviolet radiation, sterilizing anything tender that might have begun to take hold. If Proxima was a warning, this star is the warning made vivid. AP Columbae is the living image of the threat we promised you at the very start of this journey. One of those neighbors that would destroy, rather than cradle, any fragile thing that came too close. As it happens, we can find no planets around it at all, most likely for the simple reason that it is still far too young to have finished building any. But if it ever does gather worlds around itself, those worlds will be born directly into a storm and will have to weather it from their first day. There is a strange kind of sympathy in watching a star like this. We tend to think of stars as eternal and serene, but AP Columbae is neither. It is young and turbulent and alone, hurled out of the only family it ever had and left to steady itself in the dark. It has a whole long life still ahead of it, billions of years of gradual calming before it will settle into the quiet, patient old age that stars like Barnard's have already reached. Somewhere out there right now, this restless young star is flaring and shuddering its way toward a maturity it will not know for ages yet. It is a reminder that even the stars have their seasons, their violent youth, their steady middle years, their long fading, and that the calm night sky we know is really a crowd of them, each caught at a different moment of its own long story. Not every star, though, even manages to build planets at all. So our next stop is one that did, and it may turn out to be gentler than home. Chapter 8, Gliese 370, The Gentle World. About 36 light-years from Earth glows a soft orange star called Gliese 370, also catalogued with the planar name HD 85512. It is what astronomers call an orange dwarf, a star smaller and cooler than our Sun, but in exchange, calmer, steadier, and far longer lived. Where our Sun is middle-aged and will one day swell and die, a star like this burns low and patient, the kind that could give a world not billions of years, but tens of billions of untroubled ones, deep, quiet time enough for almost anything to unfold. And this patient star carries what may just be the most comfortable planet on our entire journey. That planet is a super-Earth, at least 3.5 times the mass of our own world, and it sits right at the inner edge of its star's habitable zone. So here we have a rare combination, a long-lived, gentle star, and a world sitting in just about the right place around it. On paper, it is one of the more encouraging addresses we have found anywhere in our neighborhood. When it was first found, it stood out immediately as one of the most promising places we had yet discovered to go looking for conditions something like our own. If the numbers happened to fall the right way, the temperature at its surface could be genuinely mild, not frozen like the outer moons, not scorched like the inner worlds of Wolf 1061, but somewhere in between, somewhere a human being might almost cautiously recognize. So let yourself picture standing there for a moment, on a shore of that faraway world. Above you hangs a soft orange sun, gentler and less fierce than the white glare we know, filling the whole sky with a warm amber light, the color of honey and late afternoon. Shallow seas might spread out toward the horizon, calm and warm beneath that golden glow, their surface catching the light. The sunsets would be long and slow and deeply colored, the orange star sinking unhurried toward the water. It could look, in its quiet way, like the Earth of billions of years ago, our own planet in its early days, when the first fragile life was just beginning to stir in warm, shallow water under a young sun, a gentle, unhurried, faintly familiar world. And there is a particular tenderness in imagining a place like this, precisely because it is so nearly like home without being home. It is close enough to picture standing there. You can almost feel the warmth of that amber light on your skin, almost hear the small waves of those shallow seas. And yet it is 36 light years away, which is to say, it is unreachably far, a place no human hand will touch for longer than we can foresee. It sits right at the edge of the imaginable, near enough to dream of, far enough to ache over. Perhaps that is what these gentle candidate worlds really give us. Not a destination, but a mirror. When we picture warm seas under an orange sun, what we are really doing is looking at our own young Earth from the outside, seeing our own beginnings reflected in a stranger's sky, and feeling, across all that distance, a flicker of kinship with a world we will never know. And maybe that flicker of kinship is worth more than certainty. We may never learn whether anything lives beneath that orange sun, but simply to know the world is there, to be able to picture its warm, shallow seas and its long amber sunsets, to feel that faint pull of recognition across 36 light years of empty space, that is already something our ancestors never had. For all of human history, until almost now, we imagined other worlds with no idea whether any truly existed. Now we can point to a real one and wonder about it by name. The wondering has not changed, but for the first time, it has a genuine place to land. That, in the end, may be the deepest gift these gentle worlds offer us. Not a home to flee to, not an answer to our loneliness, but a focus for our oldest question: are we alone? People have asked it around fires for as long as there have been people, staring up at the same lights, with no way at all to know. And now, slowly, world by patient world, we are turning that ancient ache into something we can actually investigate, measuring atmospheres, weighing planets, sifting starlight for the faintest chemical whisper of life. We still do not have the answer, but we finally have the beginnings of a method. The question is the same one our ancestors asked. We are just the first who get to do more than wonder. And that is a remarkable place for our species to find itself standing, at the very beginning of an answer, with the tools finally in hand. Whatever we eventually learn, whether the galaxy turns out to be teeming or silent, we are the generation that started truly looking. Gliese 370's gentle maybe, and every careful, honest maybe like it, is a first real step onto a road our ancestors could only dream of walking. But we have to hold this picture gently and honestly, because certainty is not something these distant worlds hand over easily, and it would be a kind of lie to pretend otherwise. More careful study, done since the early excitement, has cooled the hopes a little. For this planet to stay truly comfortable, rather than tipping into something harsh, it would probably need a great deal of cloud cover, more than half its surface wrapped in reflective white, bouncing away enough of its star's heat to keep the temperature in check. Without those clouds, a runaway greenhouse effect might push it toward something far too hot and heavy for comfort. So this world remains, in the end, a maybe. A genuinely hopeful maybe. One of the better candidates we have ever found, but also a quiet reminder that the difference between a paradise and a furnace can come down to something as delicate and ordinary as clouds in a sky. Out here, we do not get to promise anyone life. We only get to find the places worth asking the question about, and to ask it honestly. And that honesty matters more than it might seem, especially for a story like this one. It would be so easy to overpromise, to call each of these worlds a second Earth, to fill the dark with confident life, to give you the comforting certainty that we are not alone. But the truth is quieter and more honest than that. We do not know, not yet. What we have are candidates and questions and a slowly growing list of places worth a closer look. That uncertainty is not a disappointment. It is the honest shape of real discovery, the open, unfinished feeling of standing at the edge of what is known, looking out, not yet able to see. And there is a kind of wonder in the not knowing that an easy answer could never give. And perhaps that honesty is its own kind of gift. It would be easy and thrilling to simply declare this a second Earth and move on. But the real wonder of a world like this is not a promise. It is a question, still open, still waiting. Somewhere out there, 36 light years away, that orange sun is rising and setting over a world we can barely glimpse, and we genuinely do not know what waits beneath its clouds. Maybe warm, shallow seas, maybe a scorched and airless waste, maybe something we have not thought to imagine. The not knowing is not a failure. It is the very thing that keeps us building better telescopes, keeps us leaning out toward the dark, keeps this whole long search alive. Every one of these worlds is an unanswered letter, and we have only just learned how to read the address. By now, without quite noticing, we have drifted more than 50 light years from home. And the single most spectacular thing waiting for us out here is not a planet at all. It is a sky with 6 suns in it. Chapter 9, Castor, a sky with 6 suns. Look up toward the constellation of Gemini, the twins, and you will find a bright, familiar star called Castor, one of the steady, well-known points of the winter sky. A star people have watched and named for thousands of years. To your eye, it is a single point of light. It is not. Castor is one of the most extraordinary systems in our whole neighborhood. Not 1 star, not 2, but 6 stars, all bound together by gravity, drifting about 51 light years away. Everything you think you are seeing when you look at Castor, that one calm, modest twinkle, is in truth a whole tangled family of suns, blurred together by distance into a single spark. The arrangement of them is almost dizzying to try to describe. There are 3 pairs of stars. 2 bright, hot, brilliant white stars anchor the system at its heart, circling one another, and each of those bright stars has its own small red dwarf companion, orbiting close beside it, so that even the anchors come as pairs. Then, much farther out, a 3rd pair, 2 more red dwarfs, bound to each other, slowly orbits the entire group from a distance. 6 suns in all, nested in pairs within pairs, moving in a slow, layered, interlocking dance that takes many thousands of years to complete even a single turn. And yet, from where we stand on Earth, all of that staggering complexity, all 6 of those stars and their endless circling, collapses down into one quiet, unremarkable point of light that most people walk right past. Now let yourself do the thing this whole long journey has quietly been building toward. Forget the numbers, forget the catalog names, and simply imagine standing on a world somewhere within the Castor system and tilting your head back to look up at its sky. There would be no simple day and night here, not as you have ever known it. At almost any moment, in almost any season, at least one sun would hang somewhere in your sky. So true darkness, real night, might be a thing that almost never came. On one side of the heavens, 2 brilliant white stars might blaze together, sharp and dazzling and cold bright, too fierce to look at directly. And on the other side, low near the horizon, a pair of red dwarfs might smolder a deep, dusky crimson, staining that whole quarter of the sky the color of embers, and staining the land beneath them a soft rose. Your own shadow, cast on the ground at your feet, would not fall in one clean direction as it does at home. It would split, several faint, overlapping shadows pointing different ways at once, each one thrown by a different sun, some sharp and some blurred, some white-edged and some tinged with red. And as the hours passed, all of these suns would wheel slowly around you at their own speeds, and the colors of the light pouring over the landscape would shift and blend and change, white into gold, gold into rose, rose back into white, the whole world quietly changing hue as the suns moved. There would be no plain blue afternoon, no single golden sunset, only an endless, shifting, many-colored twilight, forever rearranging itself overhead. It is the kind of sky that would make you forget entirely what a single, ordinary sunrise, over a single ordinary sun, had ever even looked like. It would make our own sky, with its lone familiar sun, seem almost impossibly simple by comparison, and, perhaps, quietly precious for that very simplicity. And there is even a hint of something more hidden inside all this. Astronomers have noticed slight, telltale wobbles in the motion of one of Castor's stars, a faint, gravitational whisper that suggests a brown dwarf, a failed star, an object too small ever to have caught fire and shone like a true sun, may be lurking somewhere among them as well, unseen. Whether any true planet, any solid world where a person could actually stand and watch that 6-colored sky, could ever hold a stable orbit inside such a crowded gravitational maze is genuinely uncertain. It is a difficult, chaotic place to keep a steady path. But if such a world does exist, tucked somewhere in that tangle, then its skies would be like nothing our small earthbound imaginations were ever really built to picture. And that, in a way, is exactly why it is worth trying to picture it. We may never confirm a single planet in the Castor system, but the very effort of imagining a stable world inside that whirl of 6 suns stretches something in us, our sense of what a sky can be, what a day can look like, how strange and various the possibilities of the universe really are. Not every journey has to end at a destination. Some of them are worth taking simply for the way they widen the mind. And here is a thought to carry back down from that impossible sky. On a world like that, if anyone were ever there to grow up beneath 6 suns, they would find it perfectly ordinary. Overlapping shadows, shifting colors, a sky that never truly darkens. All of it would simply be what an evening looks like, unremarkable, the way our single yellow sun and our one plain blue sky are unremarkable to us. And if such a being ever looked up and imagined a world with only one sun in its sky, a world that fell into complete darkness every single night, they might find that idea as strange and wonderful as we find their six-colored twilight. It is a good reminder that the ordinary is only ordinary from the inside. Our own quiet sky, the one over our own heads on any ordinary evening, would be somebody else's impossible dream. A single warm sun, a gentle blue day, a soft and total darkness full of distant stars. We are already living on one of the strange and beautiful worlds. We just call it home. And Castor teaches us one more thing. Quietly, just by existing, it shows how much the sky hides from a casual glance. For thousands of years, every human being who ever looked up saw Castor as a single star, one plain point among the others, and thought nothing more of it. 6 suns, 3 nested pairs, a dance thousands of years long, all of it folded up into one modest twinkle, completely invisible to the eye. It makes you wonder how many of the other quiet points overhead are hiding their own tangled families, their own impossible skies, their own worlds we have not yet learned to see. The night sky is not a finished picture. It is a surface, and beneath it, everywhere we have learned to look closely, there is more structure, more complexity, more wonder than anyone standing on a hillside long ago could ever have guessed. Every star is a door, and we have only just begun to learn how to open them. And of all the doors we have stood before, Castor's may be the one that most stretches the mind, not because of what we know about it, but because of what it lets us imagine. A world with a sky that never darkens, shadows that fall 6 ways at once. Sunrises with no single sun. It is at the very outer edge of what our earth-grown imaginations can hold, and yet it is a real place. Drifting out there right now, 51 light years away, its 6 suns wheeling through their long, slow dance, whether or not anyone is watching. That is the quiet marvel of this whole neighborhood. The strangest things we can dream up are not always inventions. Sometimes they are simply out there already, waiting, in the dark just beyond our door. And Castor is only one twinkle among thousands. If a single, unremarkable point of light can hide 6 suns and a sky beyond imagining, then the modest scattering of stars over any night sky is far richer than it looks. A whole crowd of hidden systems, tangled families, strange arrangements, most of them still waiting to be understood. We have barely begun the inventory of our own small neighborhood, let alone the galaxy. Every clear night, you are looking at a surface with unimaginable depth behind it, a quiet field of lights, each of which may be a story as strange as Castor's, or stranger. The wonder is not running out. We are only just learning how to see it. Castor, in that sense, is a kind of promise. It stands there in the winter sky, one plain point of light, hiding a whole impossible world of suns, quietly insisting that there is always more than we can see at a glance. More structure, more strangeness, more beauty, folded into the patient dark. For as long as we keep looking and keep learning how to look, the sky will keep opening. There is no bottom to it. There is only the next door and the next, waiting. And that, perhaps, is the quiet promise underneath this whole long night. Not that we have the answers, we so plainly do not, but that the questions are finally within reach. A few generations ago, none of this was knowable. The nearest stars were just lights, their planets pure speculation, their skies beyond any hope of imagining. Now we can name the worlds, weigh them, sketch their skies, and argue over whether rain might fall on them. The doors are still mostly closed, but for the first time in the long history of our species, we are standing in front of them, with our hands on the latch, beginning to understand what lies on the other side. Every star we have visited, however scattered they have seemed, however far apart, is stitched into one single vast structure, an enormous bubble carved out of space itself by dying stars, and we, it turns out, live very near its very heart. Chapter 10: Our Bubble and the Direction No One Has Traveled. We have come a long way out from the sun, world by world, and it is time to lift our eyes and take in the shape of the whole place we have been traveling through. For all their vast distances from one another, every single star we have met shares one home with us. They all sit inside an enormous, nearly empty cavity in space, a region astronomers call the local bubble, roughly 300 light-years across. And it was not always empty. Millions of years ago, a series of massive stars, somewhere in this part of the galaxy, reached the ends of their lives and exploded, one after another, in a long, slow drumbeat of supernovae. The combined force of all those blasts swept the gas out of this whole region of space, plowing it aside and hollowing out the great cavern that we now, all these ages later, quietly drift through. We live near the very middle of that ancient blast zone, inside the fading echo of stars that died long before there were human beings to mourn them. And once again, as everywhere on this journey, we find ourselves sheltered. The sun's magnetic field and the Earth's patient atmosphere together shield us from the harsh radiation that still faintly lingers in this hollowed-out place. We drift through the ruins of dead stars, and we are kept safe, and we rarely even think of it. Step back far enough, and the nesting of it all becomes almost overwhelming to hold in the mind at once. Your body rests on the Earth orbits the sun drifts through the local cloud, the cloud floats inside the local bubble. The bubble is one small pocket within a single spiral arm of the Milky Way. The Milky Way itself is just one galaxy among many billions, and those galaxies are strung together like beads into vast, luminous filaments that stretch across the observable universe. Layer, inside layer, inside layer. If you shrank the entire Milky Way galaxy down to the size of a continent, then everything, every star, every world, every wonder we have visited across this whole long night would fit inside a single small neighborhood, a few streets you could walk in an afternoon. All of this, all these suns and frozen oceans and six-colored skies, and it is barely a doorstep. It is the first step outside our own front door. And before we finally turn back for home, here is one small thing you can carry outside with you the next time you stand under a clear night sky. We have talked all evening about the flat plane that the planets share, but which way exactly is up out of it? You might guess the North Star, Polaris, the star we are all taught points the way, and you would be close, but not quite right, because the Earth itself is tilted by about 23 degrees, straight up out of the solar system, does not actually point at Polaris at all. It points a little off to the side, roughly 2 fist widths, held at arm's length, away from the path the moon travels, into the faint, coiled constellation of Draco, the dragon, winding near the cup of the Little Dipper. That quiet, unremarkable patch of sky, the one nobody ever points at, is genuinely, truly up, straight up and out of the entire flat disk of planets we have been sailing across. And here is the last gentle twist. Up out of the solar system is not even the same as up out of the galaxy. The great disk of the Milky Way is tilted differently still, at its own angle, so that its up points somewhere else again. So many different kinds of up, quietly layered over one another, in a sky we thought we already knew by heart. And that quiet direction, straight up and out of the plane, holds one more small mystery worth knowing. In a strange way, it is a road almost no one has ever traveled. Nearly everything we send into space, every probe, every spacecraft, is born already moving along with the Earth, sweeping sideways around the sun in the same flat plane as all the planets. To go outward along that plane is natural and easy, but to climb straight up out of it into the empty sky above the sun's pole is enormously hard. It fights against all the motion we start with, and so, for all our exploring, the space directly above and below us, the up and the down of the solar system, remains one of the least visited directions there is. We have flung machines past distant Pluto, out toward the edge of the sun's reach, and yet the quiet emptiness straight overhead, in the direction of the dragon, is a road we have barely begun to travel. There are still, even close to home, directions we have hardly dared to go. There is something almost poetic in that, when you think about it. We imagine ourselves great explorers, and in many ways we are. We have touched other worlds, landed machines on comets, sent our voices past the edge of the sun's influence. And yet there is a whole direction, right above our heads, that we have barely entered at all. Not because it is far. The space above the sun's pole is no farther than anywhere else nearby, but simply because the way we move through space keeps pulling us sideways, along the familiar plane, never up and out of it. It is a quiet reminder that even our maps of home have blank spaces on them still, that the universe keeps some of its simplest directions in reserve, waiting, and that wonder is not only found at the far edges of the cosmos, in the most distant galaxies. Sometimes it is hiding in the plainest place of all, straight up, in the dark above the sun, in a direction almost no one has ever gone. It is a fitting place to end our wandering. We came out here expecting the wonder to be far away, in strange distant suns, in worlds with impossible skies, and we found it there, of course, in abundance. But we also found it folded into the most familiar things. The tilt of our own world, the plane our planets ride, the quiet direction straight above our heads that we have somehow never gone. The universe does not keep all its mysteries at arm's length. Some of them are woven into the ordinary sky, over your own roof, waiting patiently for the night someone finally thinks to look up and ask. So that is where our long journey outward finally brings us, not to some distant edge, but back to a direction we can point to from our own back garden, up, straight up, past the plane of the planets, into the quiet dark toward the dragon, along a road we have hardly traveled. It is a fitting place to turn around. We have crossed light years to reach the 6 suns of Castor and the frozen worlds of Barnard's star, and here at the end we find one of the least explored directions of all, sitting directly over our heads, close enough to find with 2 fists and a clear night. The far and the near folded together, the whole enormous neighborhood and the simple sky above your roof, revealed at last to be the very same thing. And with that, the journey comes gently full circle. It began with a sky that seemed almost empty, a scattering of familiar lights over a dark and ordinary evening. That same sky turns out to be anything but empty, deep and crowded and strange, and still mostly unexplored, with even the plain direction straight overhead, holding mysteries barely touched. Nothing out there has moved. The stars are exactly where they were. But a sky you understand a little better is never quite the same sky again. So where does all of this leave us in the end? One small, warm world among all of these. We have drifted past dim red embers and blazing white beacons, past a dead star crushed down to the size of the earth, and a runaway child star flung out of its nursery, and worlds where the sky holds 2 or 4 or 6 suns at once. We have crossed more than 50 light years of the emptiness that surrounds us, and met world after world after world. And in all of it, across this entire crowded corner of the galaxy, we have not found a single place that we know to be alive. Some of these neighbors may hide warm oceans beneath their ice. Some may cling to thin, hopeful atmospheres, waiting for us to look closer. Others would strip a world bare of air and life before it ever had the chance to begin. But so far, in all of this, there remains only one single world, anywhere that we know for certain, holds someone looking up and wondering about all the rest. And that world is the small one beneath your feet, right now. And that is not a lonely thought. It is a precious one. The very same darkness that separates us from all of these stars is exactly what makes our own small, warm, quietly sheltered world feel like such an unlikely and tender gift. Think of how many times on this journey we found ourselves protected almost without noticing by our star's wind, by our thin blanket of air, by the lucky geometry of living in 3 dimensions on a steady world around a patient sun. These neighbors of ours are not so far away that we cannot dream of reaching them, and even now are beginning, in small ways, to try. And yet they are not so close or so kind that we could ever forget how genuinely rare it seems to be here at all, alive and safe and able to look up. The stars around us have been keeping their slow, quiet company for billions of years already, and they will go on keeping it for billions more, wheeling gently through the dark, entirely indifferent to whether anyone is awake to notice them. And maybe that is the quiet gift of a journey like this one, not the facts, not the distances and masses and names, but a changed way of seeing home. That same familiar scattering of stars is not a flat ceiling of lights, but a deep and living neighborhood. Dim red embers hiding just out of sight, worlds where it rains or where it never will, skies stranger than any dream, all of it drifting and slowly rearranging in the dark. The sky does not look any different than it did the night before. What changes is the mind that looks at it. That is what these journeys are really for, not to make the universe smaller, but to make our own small place in it feel a little more astonishing, because in the end, that is the strange gift these distant neighbors give us. We set out to learn about them, about red embers and white dwarfs, frozen oceans and six-colored skies, and somewhere along the way, without quite meaning to, we learned something about home. That our single sun is a quiet miracle. That our soft blue sky and our gentle darkness are somebody else's impossible dream. That the very ordinariness of this world, the thing we so easily overlook, is itself extraordinary. A warm, sheltered living place, of a kind we have not yet found anywhere else, no matter how far we drift. Perhaps that is the truest reason to take a journey like this at all. Not to escape our small world, but to see it awake, to look again at the same old stars we have seen 1,000 times, and feel, for once, how much they hold, and how rare and gentle a thing it is to sit here, safe and warm, beneath a single quiet sun, on the one world in all this vast dark neighborhood, where someone is looking up at the rest and wondering. That is not a small thing. That may be the whole of it. And so the neighborhood goes on turning. Somewhere out there, past the dim red stars and the frozen oceans and the six-colored skies, all of it is still drifting slowly through the quiet dark, exactly as it has for ages, waiting for some distant day, long after this one, when we finally go out to meet it. It is in no hurry. It will keep out there, patient and shining, above a single ordinary, extraordinary sun. The neighborhood is not going anywhere. The dim red embers will go on burning. The frozen oceans will keep their secrets. The 6 suns of Castor will wheel through their slow, long dance, all of it drifting quietly through the dark, exactly as it has for billions of years and will for billions more. It will all still be there tomorrow night and the night after, waiting. So there is nothing to hold on to now and nothing to reach for. Just let the stars be where they are, far away and shining, and let yourself be where you are, here and warm and safe. Close your eyes if you like. The sky will keep its place above you, patient as ever, until you are ready to look up again.